In today's note, we're going to be looking at some trig word problems focusing on the sine law and cosine law. So these are going to be very similar to the other trig application questions that we've looked at in the last cycle for our trig ratios, or sine, cos, and tan. It's going to be very similar. Again, the biggest issue or the biggest difficulty with these will be mostly drawing the triangles and then figuring out how to solve. But once you can get down drawing or describing what the triangles are, then it should be fairly easy. But it will take practice. So again, do try the practice questions to again get into that habit, or again just have that constant repetition. So again, like I said, this is going to be looking at sine and cosine law questions. Again, the big difficulty with drawing these is that we're not dealing with right angle triangles anymore. So in this question, Jill stood admiring a magnificent Douglas fir on the opposite shore of a river. Jill measured the angle of elevation to the top of the tree and found it to be 17 degrees. She then walked 30 feet away, and this time the angle of elevation to the top of the tree was 15 degrees. Calculate the height of the tree. So we're going to need to do a couple things. I'm going to go through and actually highlight some of the important things. So angle of elevation to the top of the tree, 17, walked 30 feet away, and then angle of elevation again was 15 degrees, and we're looking for the height of the tree. So I've kind of have my small drawing here. I have Jill over here. I have the tree over here across the river. So if I want to draw exactly what happened here, I'm going to use a ruler here just to make everything nice and straight. So we know Jill is a certain distance away from the tree. So we can draw that in here. Jill is a certain distance away from the tree. We know at one point, she looked up to the top of the tree and saw that this angle here, this angle of elevation, was 17 degrees. She then walked 30 feet away and looked up again. Again, try not to focus too much on what the angles are showing here. Again, the drawing's not to scale, obviously. But she moved 30 feet away again and found that the top of the tree was now 15 degrees when looking at an angle of elevation. We then want to know, what is the height of the tree? So we want to know, what is this height? I'll just connect it over here. So we are looking for this measurement here, this height. So the first things we can do, or the first thing we want to do, is try to fill in as much missing information as we can. Right? Without doing any trig, there might be some information that we can fill in. So what we can do first is I can first fill in this angle here using what I know about my straight line kind of theory, or supplementary angles. So this goes back to grade 9, but again, the two angles here form a straight line, or 180 degrees. So if I do 180 minus 17, or 17 degrees, I get 163 degrees, which is what this angle is here. Oops. So this angle right here is 163 degrees. I can also figure out what this angle is up here, because if I look at just this triangle that I'm going to now outline in red, if I look at just this triangle, I already know two angles in that triangle, so I should be able to figure out the third, because all angles in a triangle add up to 180. So if I do 180 minus 17, I'm sorry, not 17, 180 minus 15 minus 163 equals 2. So that means this angle in here is 2 degrees. Now what I have to do, now I have to start using my trig. What I can see, or what I should be able to see, and it might take some practice or just getting used to these questions, I've already outlined one triangle in red, and I've also can see another triangle in black, right? And they share a common side. So this common side, let's just going to call that x. If I can find this common side, I can use my right angle trig, because the tree and the ground form a right angle. I can then use right angle trig to find the height. So I need to look at this in two parts. One being the triangle in red, one being the triangle in black. So I'm going to take the triangle in red and just break it apart. I'm not going to worry about using a ruler for this one. And I'm going to label in my angles that I know. So I know 15 degrees, I know 163 degrees, I know 2 degrees, and I know the one side is 30 feet. So, and I'm looking, for this side, this common side, or this long side here. So what I'm going to do now is I'm going to look and see, okay, I know it's not a right angle triangle, so it's sine law or cosine law. Based on this side, I'm solving for a side, so in order to do that, I need to have a side angle side sandwich if I'm using cosine law. I don't have this side over here, so I can't do side angle side. So that means I cannot use cosine law. But what I should be able to see is that I have half a pair here and a full pair here. It might be a little bit hard to see because the triangle is a little bit small, but I have the angle and its paired side, and an angle, and I'm missing a side. So I have a full pair and half a pair. So that means I'm using my sine law. So sine A over little a equals sine B over little b. Sine A, I know, is my known angle, so we'll say 2, divided by its side, which is 30. Sine B is 15, and I don't know the other side, so I'm going to leave it as x. With our sine law, if you're not sure how to solve this, remember, go back to the sine law note, but the first step that we have to do is cross multiply. When we cross multiply, the x comes up, so it's x times sine 2 is equal to 30 times sine 15. I want to get x by itself, so I move the sine over, so it becomes x equals 30 times sine 15 divided by sine 2. If you want to simplify this and do the top first and then the bottom, you can. You can also do it all in one step. It depends on how comfortable you are. So 30 times sine 15 is 7.76. Sine of 2 is 0.035. And if we simplify that, we should get basically rounding to 222 feet. So that means that this x value up here is 222 feet. Let me just write that. So 222. So that is what our x value is. So now what I can do is, looking at this right angle triangle, 17 degrees, we know this is 222. I'm looking for this unknown side, and we'll call it y, let's say. So because this is a right angle triangle, I can use my right angle trig. So the key things I need to do, I need to label my sides. So here is the opposite, it's across from my angle. This is the hypotenuse, it's across from the right angle, and this is my adjacent. So we got to think about, okay, what trig ratio deals with O and H? If you think back to SOHCAHTOA, only one that deals with O and H is sine. So sine theta, or an angle, is equal to our opposite side length divided by our hypotenuse. So sine of 17 degrees is equal to an unknown y divided by 222. We've talked about before, if we're missing the top value, we have to bring the bottom up and multiply. So 222 times sine 17 is equal to y. So then get a final y value when I multiply those two together of, we'll round it to 65. So that means that y equals 65. So therefore, the tree is 65 feet tall. So again, that was just kind of rounding, but the idea is we drew our triangle. In this case, it was two triangles. Based off the information that was given to us, we were able to use the sine law to solve for one side and then use our right angle trig to solve for the other side. Now, not all questions are going to require you to do both. This one did, but again, you may find other questions where you just have to use sine or cosine law. So what I'm going to do, I'm going to go through, I'm going to at least fill in the information to get you started, and you're going to have to do the calculations on your own, because again, the biggest part here is just being able to draw the triangles. So in this question here, we have a mine shaft that is dug into the side of a mountain at an angle of depression of 30 degrees. On the other side of the mountain, 6.4 kilometers away, a second shaft is dug at an angle of depression of 45 degrees. How long will each shaft be when they meet? So I've drawn my mountain here. I've drawn my two mine entrances and the mine shafts. So what I'm going to do now is label all my information. So we can already kind of see the triangle forming. So we know that one mine shaft is dug at an angle of depression. I have my horizontal already drawn. Oops, just make that black. I have my horizontal drawn, so I'm going down from that. So that means this angle is 30 degrees. The other mine shaft going down here, this one is 45 degrees. I know the two mine shafts are 6.4 meters apart, or sorry, kilometers. And I'm looking for two unknowns. So we'll call this B, we'll call this C. So I'm looking for those two mine shafts, or those lengths. So how do we solve this one? Well, again, the first step we want to do is we want to solve for any missing angles that we can use using our angle properties. Right? So this is what we would have learned in grade 9. But to find the third angle, 180 minus 30 minus 45 should get 105 degrees. So again, not quite drawn to scale, but that's fine as long as we get the triangle drawn and we have all the information labeled. Which actually I should go back and highlight. Angle of depression of 30, 64 kilometers away, angle of depression of 45. So going back to our question, I found all my missing information that I can just using regular trig. What I should see here is I should see if I want to find a missing side, again, it's not a right angle triangle. Do I use sine law or cosine law? Cosine law is the easiest to check for first because there's only two cases, the side angle side sandwich or all three sides. In this case, I don't see a side angle side because I only have one side, and I don't see all three sides because I only have the one again. So cosine law is out the window. I have to use sine law. So with sine law, I'm looking for a full pair and half a pair. So I see my full pair here, the 6.4, actually let me just rewrite this 45 degrees back a bit. So I see my full pair here, the 6.4 kilometers and the 105 degrees. I see a half pair with side B and 45 degrees, and I see another half pair of side C and 30 degrees. So this gives me my two, or all my information to figure out my two kind of steps, because I have to do two different formulas to solve for the two missing sides. So for the first side, we'll call it sine A over little a equals sine B over little b. I know sine A of my known pair is 105 over 6.4. Sine B, I know that angle is 45 over an unknown side. And that's where I'll leave it, but again, you can go through and follow the same steps, similar to the last question that we did as well. For the next one, for the other length of the mine shaft, you would have to, again, sine A, because that angle I know, or that pair I know, over sine C over little c, sine 105 over 6.4. Again, this is the same because this is my known pair. And then I have sine 30 over c, or my unknown. And again, you go through the same steps as we did before using the sine law to solve for those two missing sides. In the next one, two fire towers are located 10 kilometers apart. Exact locations are found by measuring from each tower. The angle between the fire and the other tower, or is found by measuring from each tower, the angle between the fire and the other tower. The fire has been located at an angle of 45 degrees measured at tower A, and at an angle of 70 degrees measured at tower B. How far is the fire from each tower to one decimal place? So here we know that these two fire towers are 10 kilometers apart. And we know the angle between each fire tower. Oops. We know the one is 45 degrees and the other one is 70 degrees. And we want to know how far apart is each triangle, or sorry, is each tower from the fire. So what we can do here is, again, we can find some missing information. We can find what this missing angle is, because again, 180 minus 45 minus 70 will give me my other missing angle, because again, all angles in a triangle add up to 180 degrees. So we know this is 65 degrees. What we can do now is we can use in this case, it would be the sine ratio or sine law again to find our two unknown sides. So we'll label again as B and C. So we have our full pair here. We have half a pair here. We have another half pair. So we can use those two, again, to set up the same ratios as we did in kind of the last one. So sine of, we'll call it sine A over little a equals sine B over little b. Sine of 65 over 10 is equal to sine, I'm sure for keeping it color coded, let's make this C. So we have sine 70 over C. And again, you would go through and solve that the same way as our last questions. For the other one, sine A over little a equals sine B over little b. So again, we know our A values. So 65 over 10. And then we know sine 45 over b. So then we can find those two to figure out how far away each one is, or what those distances are from the towers. And finally, the last one, at an excavation site, points A, B, and C have been marked. The measure of angle C is 132 degrees. Points A and C are 4.2 meters apart. B and C are 5.7 meters apart. How far apart are points A and B? So I have my excavation site. I have all my labeled. So this is going to basically tell me what be my 3 points of a triangle. So I just need to draw those and then label all important information. So I have A, B, and C. We know that angle C is 132 degrees. And that was mentioned to us. Points A and C. So A and C are 4.2 meters apart. B and C are 5.7. And we don't know what this point is, or we don't know what this distance is. So here what we're going to look for is, we don't know if it's a right angle or not. I'm going to say based off of this angle down here, 132, it is not a right angle triangle, so we have to use sine or cosine law. So first thing I would do is check to see if we can use cosine law, because again, we know there's only two ways. Do we have a side angle side sandwich? Well, in this case we do. We have the side angle side, so we do have a sandwich here. And it will be solving for the correct side, so we can use cosine law in this case. So cosine law, I'm going to write out the original one that we talked about. So a squared equals b squared plus c squared minus 2bc times cosine a. That's the original one we talked about, but instead, because I don't want to mess up with the labels, we're going to need to change it so that instead of solving for side A, we're solving for side C. So all I have to do now is just change all of my A values, or A letters, to C and my C letters to A. So this now becomes C squared equals B squared plus A squared minus 2BA times cosine of angle C. So all we did was just swapped around with what we're looking for. So C becomes what we're looking for, so that means A becomes part of the equation that's known. So I'm going to fill in what we know. We know B is 4.2 squared plus 5.7 squared for A minus 2 times 4.2 times 5.7 times cosine 132. Don't forget about that cosine. It's still being multiplied in there. And then you would just go through and solve this. So again, the biggest part, or the biggest thing with these questions, is being able to draw the triangles. Once you're able to draw the triangles,